Hello everyone. Welcome to today's discussion. In this series, we are planning to, for now, we are planning to discuss the uh, contest hosted on CodeChef, which is a weekly contest starters, and further we might shift to contest discussions on code forces. So we'll be planning to be consistent in series. So for now, we'll be posting regularly the contest discussions, like the post-contest discussions of starters weekly. Uh, we are a bit late for this one, but we'll try to maintain the consistency from the next one. Moving quick to the starters discussion, we'll be discussing starters 148 today. And let me just share the screen. So we'll be discussing from div 3. Div 3. Let me okay. Do we need to discuss this question, guys? Let me eat this. As first question. Let me eat cake. Please
No,
raise
sir.
your hand if anyone wants this to be discussed. Okay. Okay, then let me jump on to the next question, which is fight bots. We'll start it from the second question. Okay. Is my screen visible to you all? Hope it is.
Yes, sir.
Yes, sir.
So, this question, let me read this. Alice and Bob are competing in the finals of fight bot tournaments. The match takes place on a 2D grid, and you are given the initial coordinates of Bob and Alice, and you are given a basically string, a character string here, uh, which consists of characters like left, right, up, and down, symbolically LRUT. And what you have to tell is that the match is of n seconds, since the string is of n size. And what you have to tell is that you have to tell whether you can plan a way such that Bob can meet Alice somewhere or not. The the path of Alice is quite fixed. For every second you have the move planned, right? But for Bob, you don't. You can plan it. So you have to just tell that whether is there a way that you can meet Alice or not. So what is just a second. So here you are given with the coordinates of Alice, which are 0, comma 0 initially on a Cartesian plane, and then you are given with coordinates x, comma y of Bob, right? And I'm also given with a string, which consists of characters like L, R, U, T, where L symbolizes left, right, up, and down, respectively. So my so let's say that um, let's say that I am on the ith index of this string. Okay, let's say that I am on this ith index, and if I am on the ith index of this string, that I can say that I seconds must have passed, right? Till now, I seconds must have passed because the string is of n length, and total time is of course n second. You like spare 1 second at each character. So if you are standing on the ith index currently, then I can say that I seconds have been passed. Okay. So if Bob takes a right turn on the ith character, so there will be some final coordinate of Alice. There will be some final coordinate of Alice. Let's call it a comma b. this is an intermediary point, like intermediary step, right? Okay, so if I can say that in I seconds, Bob can reach from x comma y to a comma b, then they can meet, right? Yes or no? Is this thing
Yes,
clear
sir.
to everyone? What? Let me repeat. What I am trying to say is that you are given a string, and you take a you take left, right, or upwards, or you go downwards. You take a move, right? And um, and in intermediately index, ith index, let's say ith index, uh, the the player one, which is Alice reaches to some coordinate a comma b until ith index I seconds have been passed. So if there is a way that x comma y from x comma y Bob can reach to a comma b in I seconds, then obviously I what by I mean I is one based indexing. Okay, one based. So if Bob can reach from x comma y to a comma b I seconds, you can easily catch Alice, and then your answer will be yes. Okay. So just a second. So the inputs here are input is the coordinates, the length of the string, and the coordinates. Okay. Is this code visible to you, or do I need to increase my font size?
Yes, sir.
Let it mean. I think this would be enough. Okay. So my inputs are the test cases first, and the length, and x comma y. X comma y are the coordinates of Bob, right? And 0 comma 0 is the initial coordinate of 0 comma 0 is x. Okay. So I take a string. What I can do is I can iterate over the string, and if let's take a comma b also. A comma b is intermediately. Okay. Initially it is 0 0. Initially it is 0 0, and if s of I is, let's say, L. Okay. Then what do I need to do? I'll move a left, which means a minus minus if a denotes the x coordinate. And similarly, if s of I is right r, then I do a plus plus. Similarly, b minus minus here, and b plus plus here. B minus minus in case of down, and in case of up. Is this thing clear so far? So what I'll check that whether the absolute difference, if the absolute difference between, like the Manhattan distance, a minus x plus absolute of b minus 1, then Bob, if this is equals to I plus 1 based indexing, this is the time consumed so far, I plus 1 seconds. Okay. So if this happens, then what I'll do, I'll just simply print a yes, else in every case I will get that. Okay, is this thing clear? Okay, just run it on this one. Just a second. Why didn't take the input? So it gives yes, no, no, and yes. So is this the question clear, guys? Just a quick yes and no. Okay. Just a second. Let me share my whole screen instead. I can't share the whole screen. Okay. This was the question. So I can submit my solution here and we'll get easy, I guess. So let's move to the third question of this division, which is the undisappearance. Okay. So how many of you were able to solve this during the contest? Raise your hands. No one. Okay. This was, I would like to say that this contest was on quite mathematical kind of. You might have faced difficulty in this, but it is quite intuitive. I'll explain it to you. So the question says that you are given an array, and the array consists of only 3 characters. Okay, 1, 2, and 3. And what you have to do is that you can choose 2 integers L and R, and for every integer between L and R, you have to increment it. Okay, cyclically, 1 becomes 2, 2 becomes 3, and 3 becomes 1. Every element between L and R. And what you have to tell is that in how many ways you can perform this operation exactly once. So you have to perform this operation exactly once, choose L and R and do this operation, such that the array, the final array still contains all the elements at least once, all the occurrences. Okay. So So let's start with the discussion. The array consists of 1 or 2 or 3, right? So there will be some occurrences this. Consider this array 3, 1, 2, 1, 1, 3, something like this. Okay. So just tell me that if I choose some subarray, okay? If I choose the subarray, what I'm trying to do here is that I am trying to can anyone tell that how many total subarrays are there in any array of n size?
Okay, 2000.
No, not 2 to the power n. The total subarray count would be n into n plus 1 by 2. So all the sizes, all the sizes subarray. 2 power n would be pick not pick 3. You pick this element or not. So that can be you can say those are subsequences, not subarrays. Okay. So okay. So if I say that all this is the count of my total subarrays, and if I subtract that value, the number of subarrays which are invalid. What do I mean by invalid? I'll be telling you. invalid means that those subarrays, like if I operate on them, those subarrays, like if I operate on them, they will be always resulting into a final array where 1, 2, 3 won't be present. I call such subarrays as invalid. So if I subtract subtract the count of those subarrays from my total answer, I'll be getting my total answer, the required answer basically. Sounds good till now? Yes.
Yes.
Okay. Then moving ahead, just let's say that I'm trying to find those invalid arrays now. So what will need, I will need, let's say there are only 3 characters possible in any array, like in such kind of array, like either 1 or 2 or 3. Like if I first of all talk about 1, so if I say that if I make any of these characters like disappear from the array, then I can say that by operating on subarray, then I can include that subarray in my invalid count. Okay. So like on this example only, in this one, so if I choose this subarray, this which is marked here, like this one, okay. And if I operate on this, so just observe that if I operate on this, what does it becomes? It becomes 1 becomes 2, 2 becomes 3, and again 1 becomes 2. Okay. But still, the final array consists of all the elements 1, 2, and 3. So can I say that if I want that 1 should not appear in my array, I should choose the L and R greedily, basically, choosing the first index on the first index of appearance of 1 as my L value, and the last index of 1 as my R value. These indexes, if I choose, then what will happen? Like all the ones present, inclusive of L and R, all the ones present in this range will become into 2s, right? Leaving behind no presence of 1 in my final subarray. So that operation, like that operation L comma R, that subarray is going to count in my invalid subarrays. Yes or no?
Yes, sir.
Like, are you able to visualize it, or do I need to build it upon? What I'm trying to say is, I'm trying to say is that key. Let's say this is my array. Okay. So if I don't choose the first the first and the last occurrence of 1 as my L and R, what happens is one will be still present in my final subarray, yes. But if I choose the first and the last occurrence as my L and R, all the ones present in this range would eventually turn out into 2s, right? So what I need to ensure that for my this subarray to be invalid, what I need to ensure that this range, like the range L and R, where L is the first occurrence of any character, like for here we are talking about 1. So for this range L and R, if there is no such occurrence of any character which turns out to be 1 after applying the operation, then I can say that my subarray is an invalid subarray. What does this mean? Like let's say the chosen subarray is this, okay, 1 and 1, and few elements are here, okay. So 1 would eventually become 2, right? All the ones present here, and if any 2 is present here, it would eventually become 3. But if any 3 is present in between this range, L and R, then this will eventually become 1, and I won't be getting my desired result. What was my desired result? That 1 should not appear in the final answer, final array. Yes or no? So what is the meaning of like performing this operation if I am not getting my valid result? Yes? Is this thing clear to you, everyone?
Yes.
So far, anyone having any doubts? Okay. Okay, let's continue on this. If there is any problem like in understanding the language, you can tell me, okay? There's nothing that we have to continue in English only. I can speak Hindi as well. We can be bilingual, okay? The main motive is that the concept should be clear, okay? So far, is anyone having any problem in this? Let me summarize it for you once again. What I'm trying to do is I say that the first occurrence of 1 and the last occurrence of 1 would be my L and R. Okay. Why? Why the first occurrence and last occurrence? Because if I choose any other index, then there would exist any index other than this subarray, which will be containing 1. And what we are trying to do? What we are trying to do? We are trying to like eliminate 1 from the whole array. Okay. So for this purpose, what do I need to check? That there should not be present any character which which like construct back that element which I'm trying to eliminate. So if I call that character as conjugate, okay, let's I name it as conjugate. So what is the conjugate of 1 here?
3.
3. Okay. Similarly, what will be the conjugate for 2?
3.
1.
So 1.
1 1. A number prior to it. A number prior to it. Cyclically left shift if you do it. And similarly for 3 it would be
2.
It would be 2. Exactly. Yes. So I guess so far this thing is clear to you. Let's move ahead. So my next thing is I have the subarray, and when will this subarray when this subarray will be contributing in my invalid subarray count? When like let's say obviously L and R will be having ones. If any index in this range L comma R inclusive of them does not contain any occurrence of 3, basically the conjugate of the character, okay, so I can say that this subarray would be would be the subarray that if I operate on this subarray exactly once, then my final answer won't be having all the characters 1, 2, and 3. Yes or no?
Yes.
Is this clear to everyone?
Yes, sir.
Okay. So, so we will. So obviously we will be doing it for each element. Like we'll be searching for 1, then 2, and 3. Right? Okay. We'll be searching for the first occurrence and last occurrence of 1, then 2, then 3, and we'll be searching between L and R the conjugate of these characters. If it exists, then we can't do anything. We'll simply continue to the next character. Okay, we'll simply continue to the next character, and if 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 the conjugate does not exist, then we can take that sub-array. Okay. Now there is one thing more here. So what that thing is, like this is one and this is one. Okay, this is my L2R. So this is one sub-array for 1, 1 obviously. And let's say this is invalid for now. Invalid means that there is no occurrence of conjugate, which is 3. Then obviously final sub-array would have been like larger than this. Okay. So obviously if I try to like increase my uh, length of the sub-array leftwards and rightwards, what I can do, if this index whatever is present here, obviously it is not going to be 1. Yes, it is going to be either 2 or 3. Similarly on the right hand side it is either be going to be 2 or 3. If it is 2, then we have no issue, we can obviously include it in a sub-array. But if it is 3, we can't include it, right? Yes or no?
Yes, sir.
What I'm trying to do is I'm trying to like expand my this sub-array size, so that I can calculate the number of sub-arrays. Obviously this sub-array is contained in any other sub-array for which the starting index is less than n and the ending index is greater than equals to r. Yes or no? This sub-array would be contained in that sub-array. Do you agree with this? Yes. Are you getting what I'm trying to do? Yes or no? Okay, let me explain you once again. So far, you got that key. This is the left occurrence and the rightmost occurrence of ones. Okay, and this subarray is invalid. That means that no 3 is present so far between L and R. Now what I'm trying to do is I'm trying to like increase this size, this range. And how can I increase it? I can go leftwards till the point I encounter any 3. Why so? Because if I include this element, then 3 will be like 3 will be included in my range L2R. But I can go leftwards or rightwards. So far I do not encounter 3 or the conjugate. इससे होगा क्या? इससे होगा बेसिकली ये कि ये L से R था. Yes. So I am having this subarray. अभी तक एक ही subarray है. Okay. Let's talk in numbers. Okay. Let's say that L was 2 and R was 5. So this subarray from 2 to 5 is my invalid subarray. What if I make it from 1 to 6? If I say that no 3 is contained in 1 to 6, then is my subarray 1 to 6 is also an invalid subarray? Yes or no?
Yes.
तो इससे हुआ क्या? सबएरेज का काउंट बढ़ गया ना. मतलब अगर मैं 1 से 6 पे भी ऑपरेट करता तो भी मेरा फाइनल आंसर में 1 अपीयर नहीं होता. Are you getting this thing? Yes or no?
Yes.
तो अगर मैं ये कहता हूँ कि लेफ्टवर्ड्स में जितना स्ट्रेच कर सकता हूँ, दैट इज माय इंडेक्स 1 and this is my index 6. So these indexes, the difference between my L and the leftmost I can go, let's say that is low, and the rightmost I can go is, let's say, that is index high. So the difference between L and low will be those points or those indexes which I can include in my answer L comma R. And what I will be doing by this, I will be increasing the count of subarrays. Yes. इससे होगा क्या? So how many subarrays will be there which are invalid for a character? Those subarrays will be like L minus low into high minus R. This will be the count of those subarrays which are invalid for any character. Yes or no?
Yes, sir.
Yes, sir.
ये चीज सभी लोग समझ पा रहे हैं? L से R तक एक सब array थी, ठीक है? But what I'm trying to see कि मैं कितना लेफ्ट जा सकता हूँ? मैं तब तक लेफ्ट जा सकता हूँ obviously जब तक मुझे कॉन्जुगेट ना मिले, एंड मैं उतना राइट जा सकता हूँ जब तक मुझे कॉन्जुगेट ना मिले. इससे होगा क्या? इससे होगा ये कि हम सब array का साइज बढ़ाते जाएंगे, क्योंकि L और R फिक्स है, उनको नहीं मूव कर सकते हो तुम. What you can do is you can include the element which is left to your L, or include an element that is right to your R. तो उससे होगा ये कि तुम्हारे सब arrays का काउंट बढ़ जाएगा. Obviously if you जो अभी मैंने ऊपर बात कही कि if 2,5 is your L2 bar, obviously if 1,6 is also valid, then 2,5 is contained in 1,6. And if you choose your L and R as 1,6, then also you will be getting the same answer. Yes or no?
Yes, sir.
ये चीज सभी को समझ में आई कि ये जो भी फॉर्मूला है ये काइंड ऑफ कैसे जनरेट हुआ, मतलब ये नंबर ऑफ सब एरेज कैसे आ रही है?
Yes, sir.
Yes, sir.
Okay. Let's move ahead. Now let's talk about the implementation part. कि obviously we'll be doing this thing for all the characters 1, 2 and 3. Now let's talk about the implementation part. ये होगा कैसे? तो सबसे पहले what we need is L comma R, the first occurrence and the last occurrence. And how can I get it quickly? I can maintain a prefix. Okay. How can I maintain it? Like, let's say 3, 1, 2, 1, 2, 3. Okay. So I'll be maintaining my prefix. Either you can maintain 3 different prefixes, or you can maintain prefix in a 2D array. Okay. So what it will seem like? It seems like either 1 or 2 or 3. These are possible 3 characters. So the prefix of 1 would be like 0 here, and 1, 1, 2, 2, 2. For 2 it would be 0, 0, 1, 1, 2, 2. For 3 it would be 1, 1, 1, 1, 1, 2. Okay? Is this thing clear?
Yes, sir.
अब हम अपना L और R कैसे निकालेंगे? हम अपना L और R ऐसे निकालेंगे. From the left, the first time we get I and I plus 1 to be different. That is going to be my first occurrence. Similarly, from the right, the first time I get my I and I minus 1 to be different. That would be my rightmost occurrence. Yes or no? This is going to be my N and this is going to be my R.
Yes, sir.
How you are using prefix array to find the leftmost and the rightmost occurrence. the first time when the value changes, that would be your first occurrence, and the last time your value changes, that would be your last occurrence. Obviously, yes or no?
Yes, sir.
Yes.
So now what you have to do next is you have, let's say this is L and this, just a second. Okay. Let's say this is L and this is R. So you got your L and R. Now what you have to check? Whether there exists any occurrence of that conjugate. Let's say, let's call that conjugate as value K. Okay. So if conjugate exists or not between this range, that can also be easily implemented or done by using prefix array. So for the prefix array of K, what is K? K is a character, obviously, either 1 or 2 or 3, conjugate here. If I say that prefix of K, and if I subtract the value on indices R minus the value on the left index, and if this comes out to be 0, and if this thing comes out to be 0, what does that imply? That implies that there is no occurrence of value K here. Yes or no? Why? Because the value didn't change at L and at R. It was same in the prefix array, of course. Yes?
So please repeat this part.
Okay. Just what I'm trying to say, consider this is my let's say that I'm looking at my conjugate is currently 1. Okay. You got what is conjugate?
Yes, sir.
Okay. So if I'm looking for 1 between L and R, I will look upon the prefix array of 1. What does the prefix array of 1 has to say? Let's say the prefix array of 1 looks like 0, 1, 2, not 2 here. Let's say it was, okay, it was 2. Let's say 2, 2, 2, 2, 2. Okay. And if I say this is my L and this was my R, so the value at L and at R is same in my prefix array of my conjugate. What does this mean? This means that इसके बीच में वैल्यू नहीं बदली ना. नहीं बदली का मतलब क्या है? There is no
So
occurrence
one-
of conjugate between.
Yes, sir.
Now is this thing clear?
Yes.
Yes, sir.
To everyone?
Yes, sir.
Okay. So I think this much is enough for explanation. Let's move to the implementation. Okay. So what is my input here? Okay, so it is just an array. So n is an input array, n is size of the array, and then there is okay. Now my first task is to construct prefix. Yes. So what I'll do, I'll maintain a 2D vector. Okay. 2D vector of size, let's say 4. Vector of size, let's say 4, and I initialize it with a vector of size in this one and with 0 to 5. Okay. So what I'll do here is I'll go from 1 to 3. I'll go for each character, and what I'll do, what I can say, a prefix of I. I means that character, either 1 or 2 or 3. My prefix of I, and j is my current index in the array. So j plus 1 is equals to prefix of I and j. So if my array, like if my array had, like j is my current index, if my array had that value which I am looking upon, that is I here, what I do, I do a incremental prefix of I and j plus 1. So this is my prefix array. Is this thing clear how I'm making this? Yes? Yes or no? Prefix array implementation clear है सभी को? Am I audible?
Yes, sir, you are audible.
Okay. Then my next task is, what is my next task? I have to find L and R, right? So let me iterate it. The characters are from 1 to 3, and I need L and R. Let's say my L to be as low. L. So my L will be like the lower bound of prefix of I am looking upon, which is currently I. I'm looking upon by 1, the first occurrence of 1, right? In prefix array, the first occurrence of 1 would symbolize that there is a change from 0 to 1, because initially it would be 0, and if I search for the lower bound of 1, it is going to give my value of left. Yes or no? Are you able to get this? Why I'm using? You can traverse also. Okay. For simplification, I'm using lower bound. Like you can traverse too. Lower bound of prefix of I, and I'll be searching here for prefix of I, the last value. But what if the last value was 0? That means that already there is no existence of 1, 2, and 3. So is it clear that how I am getting my L and R? Yes? Yes or no?
Yes, sir. Sir, in prefix array, सर जब प्रीफिक्स ऐरे बनाए हैं आप, तो सर उसमें जब चेंज आ रहा है तो हम लोग J+1 में एडिशन कर रहे हैं ना?
Just a second.
तो जैसे फर्स्ट अपेयरेंस ऑफ 1 जब आएगा तो हम लोग उस फर्स्ट जिस इंडेक्स पे 1 है वहां पे तो इंक्रीमेंट नहीं कर रहे हैं, उसके अगले इंडेक्स पे इंक्रीमेंट कर रहे हैं ना?
क्योंकि प्रीफिक्स एरे 1 बेस्ड है, मतलब कि
ओके
जिस जिस 213 में दिस इज माय जीरोथ इंडेक्स, माय j is 0, बट माय प्रीफिक्स एरे में दिस वैल्यू वुड बी 1. This index is second index and this is third index. So I will be incrementing in j+1, not in j. Is it clear
ओके
now?
यस यस।
See, if I print my LNR, I need the index, not the value. What I will do, I'll subtract this thing from prefix of I dot again, because lower bound gives me an iterator. This will be giving my index. Yes, it works now. So 2, 2 is the first occurrence of 1 and the last occurrence respectively. 1, 1 is the first and last occurrence of 2, and 3, 3 is the first and last occurrence of 3. So this is sorted. Now what I need to find is, I need to find my conjugate. Conjugate is I minus 1, and if I is 0, my conjugate will be 3. Okay. Now I need to check whether there is any occurrence of k in my range. So if, like, prefix of I, not I, I'm looking in the prefix of k at index r, yes, at index r, and prefix of I, not I, k, prefix of k at index l. If these values are same, that is the difference is 0, then I'll be having my answer. And what will be my answer? Let's say I declare my global answer as n into n plus 1. What I do, I'll calculate now low and high. Low would be L initially and high will be R. Low would be L and high would be R. Now what I'll do, I'll move left while low is greater than equals to, when the array at index low is not equal to the conjugate, what I'll do, I'll do a low minus minus while my array of high is not equal to the conjugate, what I'll do high plus plus. And finally, my total subarray count would be n minus low into I minus R. Yes. And I'll simply subtract it from my answer. this. If my prefix of R minus prefix of L in the conjugate is 0, that means that it is invalid, and I have my low and high initialized to L and R, and while my P of low is not equals to K. Okay. It comes out to be 1/2, और यहाँ पे होगा L minus 2 into I minus R plus 1. अब आएगा 2011, I think हो गया. Let me count this out. So this is my implementation and gets asked. तो इम्प्लीमेंटेशन समझ आ गया तुम लोगों को ना?
यस सर.
एक और बात बता देता हूँ. कुछ नहीं, बस मैंने प्रीफिक्स एरे बनाया, फिर मैंने प्रीफिक्स एरे से एल और आर निकाला लोअर बाउंड यूज करके. अगर लोअर बाउंड नहीं समझ में आया तो व्हाट यू कैन डू इज you can use 2 pointers and check whether one is not equal to other and you can break there. इस तरीके से भी निकाल सकते हो. बेसिकली एल और आर आना चाहिए, ठीक है. उसके बाद I check that whether R minus L पे prefix value conjugate की prefix value 0 है कि नहीं. This is implying that the value is same at both indices L and R. फिर मैंने lower high निकाला, ठीक है. Lower high निकाला and I use this formula, this thing I explained it before, to calculate the count of sub-arrays, and I decreased it from my final answer. Okay, and let's quickly move to the next question. This is going to be a last question for the discussion. This is double cover. So this question, my screen is visible, right? Screen is visible to you. So what the question says, the question says that you are given an array and you must perform the following operation exactly k times. What you can do, you need to multiply any element, you choose any index and multiply ai by 2, and then replace ai with 2 times ai, okay, and find the minimum possible sum of the array. So greedily we think that to find the minimum possible sum of the array, and if I have to multiply every element with 2, what I need to do is I'll just look upon the smallest element of the array and I'll simply multiply it with 2. Then again I'll look upon the smallest element, again multiply it with 2. Till when? Exactly k times. Okay. But the problem here is that k is going till index 10 to the power 9. Right? And for the subtask, it said that k is less than equal to n. And what is n? N is like 10 to the power 5, order of 10 to the power 5. It means that you can do it in O of n for that subtask 1, and for subtask 2 you have to optimize. Okay, so I directly jump on the optimized approach basically. There is like this is like quite easy. I had this thing in my mind, but I couldn't implement it on time. Just a second. So if my k is like of the order less than equal to k to the power. तो अच्छा इसमें ऐसे देखो कि what I need to do. Let's say if k was less than equal to n, what I would have done, I would have just maintained a kind of multi-set or a priority queue maybe.
Yes.
Why priority queue? Is this thing clear to everyone? Why I'm using a multi-set or priority queue?
To get the minimum element first.
Yes. I extract this element, multiply it by 2, again insert it in this data structure. And all these elements get sorted again, and the complexity of that is log n. And I iterate it over the, I basically iterate it or do it for k times.
Okay. Yes.
Complexity comes out to be k log n, right?
Yes.
But that won't work in the scenario when k is of the order of n to the power. So what we can do here to optimize is a simple greedy approach would work here. What is my greedy approach is? Have you heard about AM or GM? Like AM becomes equals to GM. Okay, if this is not relevant. Let's say that let's take an example. Let's say 1, 2, 6, 9, and let's say 27. Okay. Let's say this is my array. This is sorted. So if I say that if I keep multiplying this first element, like the smallest element, with 2, then it would find its place when the elements would rearrange. जब ये दोबारा rearrange होंगे, then कुछ और arrangement होगा. Then smallest element कोई और हो सकता है 2 हो या हो सकता है 6 हो. You don't know. Yes. But what if
Yes,
I say कि अगर order मतलब ऐसा सोचो कि अगर सारे एलिमेंट्स बराबर होते हैं, लाइक ऑल एलिमेंट्स वर 2 2 2 2 2, तो क्या ये ऑर्डर चेंज होता? मतलब अगर मैं इसको मल्टीप्लाई कर दूं 2 से, इसको भी मल्टीप्लाई कर दूं 2 से, इसको भी, सब एलिमेंट्स को अगर 2 से मल्टीप्लाई कर दूं, तो क्या ये ऑर्डर चेंज
No,
होगा?
sir.
अगर सारे
No,
एलिमेंट्स
sir.
इक्वल है. यस. अब ऐसे सोचो that so my array was 1 2 6 9 and 27. One. So what I'm trying to do here is I'm trying to make all the elements nearly equal. I can't make equal, I can make nearly equal. What I'll do by making them nearly equal, I'll tell you a bit. Let's say 27 is my max element. I'm trying to make it nearly equal to the max element. What I'll do, 1 को 2 convert करेंगे, then 2 to 4, 8, 16. What I mean by nearly equal is less than equal to the max element. 16 times 2 is 32. I won't go beyond 16. Yes. Then similarly for 2 it will be 4, 8 and 16, and 6 के लिए हो जाएगा 12 and 24. For 9 it will be 18. Yes. So this thing is going to take not much operations. It would be like order of log of max element at max. Yes. And okay. So what my final array becomes after doing these operations, it becomes 16, 16, 24, 18 and 27. If I sort this array, okay, what does it becomes? becomes 16, 16, 18, 24 and 27. Now these all elements are sorted and they are nearly equal. What I mean by nearly equal is that if I perform the operation on the first index, the first element basically, it becomes 32. I don't care where it will be where it will be having it position after that, after this operation. But what I'm pretty sure about is that my next minimum element on which I will be operating would be the next element to the current element. अगर मैंने फर्स्ट एलिमेंट पे ऑपरेट किया था, then my next minimum would be my second element, and my third next element would be the third element, and the fourth next element would be the fourth element, and so on. And once I complete my operations till the last index, again I will be in the same position. मतलब 16 को 32 किया, इसको भी 32 किया, 18 को 36 किया, 24 को 48 किया, and 27 को 54. The order remains the same. Order बदल नहीं रहा, so you don't need to maintain a like multi-set or a trie queue here, right?
Yes, sir.
So does this thing anyhow helps us to solve this? ये सबको समझ आ रहा है ना? Why did we like make this nearly equal?
Yes, sir. ताकि सर log n की जगह 1 लगने लगे complexity.
हाँ, मतलब basically what you can do now is, मुझे इतना तो समझ में आ रहा है कि अगर मैं सारे एलिमेंट्स में 2 मल्टीप्लाई कर देता हूँ, then the order doesn't change. तो अगली बार जब मैं सेकंड राउंड में, जैसे मतलब मान लो n की वैल्यू 5 थी और k जो तुमको करना था that was 10, है ना? तो मैं instead of like multiplying 10 times, what I will do, I'll simply calculate कि हर एलिमेंट को कितनी बार मल्टीप्लाई करना है 2 से. That would be like k by n. Yes. और हर एलिमेंट को अगर मैं 2 to the power k by n से मल्टीप्लाई कर दूं, that would be resulting in my final sub array, मतलब final array. For example, यहाँ पे 5 और 10 था, तो instead of multiplying these 5 elements 2 times with 2, I'm only multiplying them 1 time with 4. This is what I'm trying to say. ये चीज समझ आ रही है?
Yes.
सभी को समझ आ रही है?
Sir.
Okay. So what I'll do is, first of all, I'll try to make all the elements nearly equal to the max element, and then I'll sort them, and then I can simply say that my order does not change. The order does not change means the order in which those elements are arranged. If I multiply all the elements, remember all the elements by some constant value, like the elements were, let's say, a1, a2, a3, and the order was a1 is less than equal to a2 less than equal to a3. If I multiply this whole inequality with a constant k such that it becomes ka1 less than equal to ka2 less than equal to ka3, this thing holds, yes or no? ये तो पढ़ा होगा मैथ्स में.
Yes, मतलब से यहाँ एक solution है कि तो सबसे पहले हम लोग नियरली इक्वल करेंगे सबको, उसके बाद जो नंबर जितने नंबर टूज बच जाएंगे उनको डिवाइड बाय n करके मल्टीप्लाई कर देंगे ऑप्शन से.
हाँ, मतलब डिवाइड बाय n क्यों करना है? क्योंकि वी आर डिस्ट्रीब्यूटिंग देन इक्वली.
यस सर. यस.
इक्वली डिस्ट्रीब्यूट इसलिए कर रहे होंगे क्योंकि जब हम A1 में एक बार 2 मल्टीप्लाई कर देंगे तो A2 अगला मिनिमम एलिमेंट बन जाएगा.
Yes, sir.
समझ रहे हो? Then if I do this thing n times, then again I will be at the same position, like on the same like orientation of this array. ये चीज समझ आ रही है?
Yes, sir.
Okay, great. And this was the only tricky part here, and obviously implementation में एक tricky part है. तो अब क्योंकि we are
सर अगर हमारे पास इनफ टूल्स नहीं है तो
हाँ मैं बता
जैसे
तो if k is less than n, okay, that means like the remainder कुछ remainder बचेगा like k modulo n, okay.
yes,
तो what you can do is k by n times तो तुम directly distribute कर सकते हो, right? But k modulo n times जितने times वो remainder बच जाएगा, ये जो array होगी you will be at the same position, like a1 is less than equal to a2 less than equal to a3. तो ये जो k modulo n जो remaining number है, इतने टाइम्स तुम स्टार्टिंग के नंबर्स में मल्टीप्लाई करोगे बस, क्योंकि वो मिनिमम होंगे, वो सबसे छोटे होंगे.
मल्टीप्लाई करने से तो लास्ट हो जाता है.
हाँ, पूरी एरे को पहले फाइनल एरे बना लो जो दिखेगी, एंड देन यू ऐड देम.
yes,
ठीक है? लॉजिक इज क्लियर टू एवरीवन? हम कर क्या रहे हैं?
Yes, sir.
ओके.
सर एक डाउट है सर, अगर हमारे पास इनफ टूल्स ही नहीं, मतलब कि हम उसको नियरली इक्वली नहीं बना पा रहे हैं.
अगर हम नियरली इक्वल नहीं बना पा रहे हैं तो ऑब्वियसली हम कम कॉम्प्लेक्सिटी में काम कर लेंगे.
यस सर.
तो के खत्म हो जाएगा ना भाई. यू गेट दैट?
यस सर. यस सर. थैंक यू.
लेट्स क्विकली कोड इट अप. So my inputs are n, k and the array. N, k and the array. So what I will do? सबसे पहले हम उनको नियरली इक्वल बनाने की कोशिश करेंगे. So इस पर्पस के लिए let's take a multiset. And let's insert all the elements of array in my multiset. And what I'll do, while st dot begin into 2 is less than equal to max element. What is max? Well, max element. Max would be like the last element of max. So while st dot begin into 2 is less than equal to max and k is remaining, what I do, I insert st dot insert 2 times st dot begin in my set, and I'll erase the first element. Is this thing clear?
Yes sir.
Yes, sir.
Okay. I'll switch this with the st dot erase. So far I'll be having all the elements nearly equal. Yes. Then I'll take my question. My question will be n k by n, and my relator will be k modulo n. And I'll calculate the power of 2. This power function here, let me show you this power function. So this power function is just okay. What it does is, let me explain it to you kind of. This is binary exponentiation. Okay. This power function is doing a binary exponentiation. Also, at each step, it is doing a modulo 2. This thing is important because the numbers are huge we are dealing, and we have to return the modulo answer, right? So keep this in mind while you are calculating the power using binary exponentiation. Also include this thing. Okay. So binary exponentiation with modulo, and we will be calculating 2 to the power k by n. And what I'll do, k like q times, I'll be multiplying val in my answer. And let me take my vector. Like so far my answer would be sorted in the multiset. If I insert all the elements of my multiset in my vector, those will be also sorted, and this is the order I need to maintain. This is the order I need to maintain. So what I'll do, for every element, like k by n times, तो मैं पूरा मल्टीप्लाई कर सकता हूँ सबको 2 से. So इससे अच्छा मैं बार 2 से मल्टीप्लाई करूँ, मैं 2 की पावर k by n से मल्टीप्लाई कर दूंगा हर एलिमेंट को. What I'll do, I'll be like vec of I equals to vec of I modulo mod. Mod is 1 in n plus 7 into val modulo mod. Like this is modular arithmetic. Okay? So I'll multiply this vec of I with my val. And finally, what I need to do, I again need to settle down these k modulo n values, that is my remainder. So, like, till I go till rem, like this much of time, I will be again doing the same thing. Yes or no? At last, I'll calculate now. Sum equals to sum modulo mod plus I modulo mod. And at last I'll print my sum. So my test cases are this. $40, 316 and अच्छा यहाँ पे हम एक मिनट, just a second, हाँ I get this. We'll be not multiplying it by val here, right? Remainder times, so we'll be just multiplying it with 2. Yes or no? Modulo.
Yes sir, yes.
Yes, sir.
Vec of I would be equals to what is this? इसका sum क्या होगा? 27 and 3 is 30, 39 and 4 is 43. Sum क्यों गलत कैलकुलेट हो रहा है? अच्छा V में कर दिया ना, my current updated अब ठीक लग रहा है. I think this should pass. Okay. Okay. So that was all, I guess, for this PCT.